All right. Good afternoon, everyone. This week, this is week 11 of, the end of, excuse me, the end of week 11, uh, class of 2025 Network Cabling, Fenchurch College, ELEC 1013. Summer course or summer term, not summer course. It is summer course, but it is a legit summer term. All right. So this week we are talking about the fire alarms, security alarms, and surveillance alarms. And the reason for that is that network cabling, as the course is called, it has a lot to do, or pretty much the core objective of this course is to familiarize you with the network infrastructures, and that goes as vast as the world is. So it's not just, as I say, it's not just running a cable from point A to point B and terminate them at both ends and hope that everything is okay. Well, yes, there's a lot of that involved. However, you will be required to familiarize yourselves with a lot of different systems, be that security alarms, fire alarms, which fire alarms is a little bit different. However, it kind of overlaps. So I included that in this unit. But for fire alarms, you need additional licenses. And if you're interested, talk to me. I will point you in the right direction in our college. Surveillance systems, which is basically popularly known as security cameras. That is a popular thing to do. All that is a moneymaker, not because you're greedy, but this whole objective of this game is to know how to do something so you are able to support yourself and find a legit job or start your own business. So there are different things. Things that we're not mentioning here in this unit is a lot of other systems. Will be sound systems, school PA systems, otherwise, which we already talked about. So now there's a little bit more I'm giving you, to kind of broaden up your horizons and see if something triggers within you, if something strikes your interest. Anyways, I always, as I say, all this stuff that I'm teaching you, I have done it all right? And not just like 1 day or 2 days just to try it out. There were periods in my life, in my whole, if you might say, career, professional career, if you can say that. I was involved quite heavily in all of the stuff that I'm showing you. Right? So 30 years or over 30 years, things accumulate. All right. So as I said, if there's something that you like, talk to me. I will point you in the right direction. I will set you up with whatever you need to. I will help you with that. Okay. Yeah. All right. So today you are going to get the second part of the security alarms. And tomorrow, when we meet in person, I'm going to give you the first part of this presentation. It's just so I can sort things out on YouTube playlist, so all the parts are present. Right? It just works out this way, that way, today. This way, that way. All right. So here are the zones. Just bring it to the full screen here. Here are the zones of a security alarm. Now, that's from the main board. This is this part of the main board. The other parts I will discuss with you tomorrow. So, zone is a contact point. So this is just a review from the last presentation, which you haven't seen, but it's already on YouTube. Zone, what this is, it's a contact point. All right, let's see. This is a zone, which would be zone 1, zone 2. This particular board has 8 zones. So this is an 8 zone system. So let's say zone 1, we have connected to the main entrance, and we're going to name it in the programming to front door or side door or whatever the main entrance it is for you. And let's say we have programmed that zone to be an entry delay zone. You have some, at least in most alarm systems by most brands, you're going to have at least 2 delays, programmable delays. And by default, the entry delay would be 30 seconds, and by default, the exit delay would be about a minute. What's an exit delay? Well, you arm the system, and the system starts counting down to the point that it's going to arm itself. So you have basically a minute to get out. So that's an exit delay. Well, while you're getting out, you're triggering the motion sensors and you're opening the door and closing the door and all that stuff. So during that minute, the system is, not going to trigger the alarm. But when that countdown is done, the minute is passed, the click, the system is going to set itself up to be armed. So that's an exit delay. Entry delay is that when you enter the house or the building or the premises, and you have to trigger certain things. It's like, for example, you have to open the main door, which is also armed. So you don't want the alarm to trigger right away. You don't want this zone to be an so-called instant zone. The entry delay will give you, by default, 30 seconds. So you have 30 seconds to punch the code or do whatever that you have to do to disarm the system. And both delays can be programmed to whatever your liking would be, but for the most part, entry delay is 30 seconds, but you can change it in programming. Exit delay would be 1 minute, but you can also change that in the programming. Of course, some of the systems have more than one delay for whatever reason you wanna use, but you should have at least 2 types of delays. And with the modern systems right now, they are programmable. So let's say this is a zone. To zone 1, you could do a closed loop. Well, the simplest thing would be to run a wire from the common to that zone 1 terminal. Just short piece of wire, 1 inch long wire. Well, or you can disconnect that wire and make that zone open, or you can connect that wire and make that zone close. Well, that's how it works. So zone 2, you could have, well, let's say living room windows. And if the living room has more than one openable windows, you're not going to put every single window on separate zone because you're going to run out of the zones quite quickly. So you could combine those 3 windows onto zone 2. You can connect them in series. So add, for example, the zone 3, you can set up to be the living room or the downstairs motion sensors. Zone 4, you can do, maybe glass break detectors on the east side of the building or the living room, or whatever else. And those common points are just, they are the same point. That's the same point electrically. They're connected, but they're placed strategically, conveniently. They're placed along this connector here, just for the convenience, because every zone is connected to the common point. Every zone connected to the common point to make a closed loop, common point, and so on. This one is closer here, I connected to that one. If you connected to this one, that's fine too, because they're the same point. So let's say zone 1 would be the main entrance. So this is the zone 1 here. That's a review from the last presentation. For example, that's the zone 1. That would be this point right here. And the common would be this point right here. And instead of connecting it straight to itself with a little piece of short wire, you can extend that loop and connect it through something that's called a reed switch, R-E-E-D, reed. It's just like the reed in the saxophone mouthpiece, right? Because it looks like that, sort of. It's got two metal pieces that are close to each other. And if you don't have the magnet, this would be the magnet. If you don't have the magnet in close proximity, that switch is open. If you bring a magnet close to it, it closes. So, well, one way of doing this thing, this would be mounted on the door frame. And this magnet here would be mounted on the door itself that swings out open. It makes sense because this switch here can be mounted on the non-movable part because there's wiring involved, so you can bring wires into it. And the magnet is just a magnet, doesn't have to be wired. It just gets close to the switch and far away from the switch. If it gets close, if it's close to the switch, switch is closed. You can do that by closing the door. So you open the door, switch opens. Okay? So that's mainly, so you can say for the most part, there could be some other configurations, but for the most part and by default in most of the alarm systems, the zones are set up to react when it's open. So it has to be closed. This thing has to see the closed loop. We're going to discuss other configurations later on today. As opposed to fire alarm, it works the opposite. It's an open loop with something that's called an end of line resistor, and then when you trigger the fire alarm, you're closing the loop. With security alarm, you're opening the loop. It's just how things are set up. Okay? So this would be the zones. Serial port, we talked about that in the previous presentation today with the other group, and I will talk to you about that tomorrow while in person. Battery or backup battery. This is a 12-volt battery. This one is 7 amp hours. That can give you 1 amp for 7 hours. Or their smaller one, it looks almost like a half of that, 4 or 5. I think it's 4 amp hours for that. So I usually get the bigger ones. It's a lead acid battery, sealed, because in the car, you might have a sealed battery or not. The vapors, they disperse into the air. But when you have that enclosed system, closed by the box, and it's somewhere in the basement or somewhere, wherever closet you have that thing in, you don't want the vapors to be escaping and floating around. So this has to be a sealed battery, and those batteries are made specifically for example, like alarm systems. Yeah, it actually says sealed lead acid battery, same as the car. So it has to be charged all the time. So there's a circuitry in the main board that keeps charging the battery. It's a backup battery, and as I said in the other presentation, it lasts. It gives you a little bit of time when the power goes down. So the power is not powering up. The main power is not powering up the board. So just so the system still works, the backup battery kicks in. And as I said in the other presentation, clients will always ask, it's almost guaranteed, that they're going to ask, okay, so how long do I have? Well, you can't tell. You can't tell because depends on how many other devices are connected to that main board that this battery still has to, so how many motion sensors you have, which require power to operate, how many glass break detectors you have, which require power to operate, how many keypads you have, and so on, expansion boards and some other modules that require power. Everything requires. So whenever you're connecting a motion sensor or glass detector, the glass break detector or something else, you're going to have to read in the specifications, which is going to be included in a piece of paper, in the box, in the packaging, to see what is the current draw that this thing draws. So whatever the devices you have, you just add them up, and that's going to be your current draw for the alarm system. And uh, you connect those devices to the power output of at the main board, not to the battery. Right? But the more devices you have, the less time your battery is going to have. So it depends from one situation to another. You can't specify or guarantee. In fact, you can't guarantee anything when it comes to security alarm. And when I was doing this as my own business, I actually had a little bit waiver that the client had to sign if I release the system to them, that they understand that having a security system or security alarm system uh, does not give you a guarantee that nobody's going to break into your home. It's a piece of electronics equipment. Electronics do malfunction from one time to another. Anything can happen. There's no guarantee. So, you don't want to get sued. They say, oh, I thought it was a guarantee. No, there's no guarantees in life. As many of us know, there's no guarantees to anything. Excuse me. But the legalities, you got to take care of. Now, as far as the zoning, and over here, I have a little bit of a home wiring. So I would encourage you to watch that little video here, so you get a little bit more. But let's take a look at the two different scenarios for connecting a zone. And in this case here, we're looking at the passive devices, and a passive device is a device that does not require power to operate. Like, for example, this reed switch that I just showed you. And this is a surface mount type of a so-called door contact. And door contacts, you mount it on the door frames and the doors, and you also install them in the window frames and the windows opening part that moves. But we're not going to call them door contacts and window contacts. It's all the name for that. It's named door contacts. Okay, just so we know that. So over here is the reed switch, and how is the reed switch operate? It's like this. Like, let me just give you a bit of a magnification of that. Here is the switch, and it has two metal pieces, just like that. Let's say maybe like this, and they're not touching. And these are connected to different terminals. This one can be connected to here, a screw terminal, and this one can be connected to another screw terminal. So you have something like this here. All right. You bring a magnet in close proximity to that. Let's say this is a magnet in a casing, and inside it's like a tubular type of a magnet glued on or whatever. And this would have probably mounting screws, and this will also have mounting screws here somewhere, right? They are different manufacturers. They have miniature switches and regular, not miniature switches, depending on the situation. I always carried like half a ton of one kind, half a ton on the other kind, and maybe another half, not really half a ton, but a couple boxes, which would be like 20 or 30 always in my van I'd have. There would be those flash mounts, so would be the switch would be like this here. Okay, something like that. And the wires, the screw terminals would be here, or there could be wires coming out of that. So we could have a choice. And that would be mounted in the door frame, actually. So that would be the door frame. Okay, just like that. So this would be flush with the door frame on the bottom, on the side, or on the top, whichever you decide. And the magnet would be also tubular kind of magnet that you drive into the door frame. Right. So door frame will be actually the door itself. So this should be like the other way here. Let me just it will be like this, right? This would be the door frame, and this here would be the magnet that will be driven into the actual door. Right? Makes sense, because if you mounted that on the door, the wires will be broken because you would rip the wires out of it. The door frame is not moving, so and it will be flash. They were called flash or in-frame connectors. Right? So that's how. Why is it called reed switch? It's because those two pieces, they look like that reed in the saxophone mouthpiece or clarinet mouthpiece. That's they call it reed switches. Now, notice two different scenarios. Over here, we have, well, I mentioned already, it's a passive device. So we use something that's called the Z wire. And the Z wire is, well, small diameter type of a cable, mostly used in security alarms, with not twisted pair. You don't want a twisted pair in the alarm contacts. And I explained that already in the previous video. Basically, twist acts as an inductor or a coil. Coils do not like change. They will block the change. And the faster and more aggressive the change happens, the faster and the more aggressive the coil gets with blocking it. So if you open and close the door very fast, very quickly, the signal might not get into the panel that the door was actually opened. So that's why you need straight, untwisted pair. And the Z wires, the Z number says, okay, it's Z4 wire, or in America, they would call it Z. Right? So Z4 means it's 4 conductors. And that would be, remember the old color code for pots? Red, green, black, yellow. So we connect those a little bit different because one pair in pots would be green and red, or red and green. And the other pair would be black and yellow. And if it were a third pair, it would be white and blue, and so on. There's a different color code there. But in security alarms, we use the green and yellow as a signal wire, and the black and red we use for power if we need to use that. But we would not use the red and black in this case because this is a passive device. It doesn't require power to operate. If this were a motion sensor, you would run the black and red into the power terminal of the motion sensor, and this green and yellow, you would run it to the, well, the motion sensor will have a dry contact relay. So if it senses motion, it would click the relay into an operation, and normally you would connect the green and yellow wire to the normally, well, closed part of the relay. If you don't know what relay operates like, well, I would encourage you to, because this is not about that, but I will tell you maybe when you in person tomorrow how the relay operates. I just don't want to spend time on in this class doing that, because this is not the point. However, I'll tell you that tomorrow in person. So you would connect that to the normally closed. So when the motion sensor clicks into the operation, because it detects motion, it clicks the relay, so it becomes the normally closed terminal becomes open, and the loop is open. The zone senses an open loop, and it reacts. If the system is disarmed, then but I don't want to keep repeating myself, but still have to say it because this could be video standing on its own. Then open loop triggers a reaction. If the system is armed, then it's going to go into alarm state. If the system is disarmed, it's just going to display on your keypad that the side door is open or the bedroom window is open or something like that. Now, you can see that in this case, this is just a closed loop. And you see a little bit of a resistor here. What's up with that? Well, when it comes to programming the zones or setting up the zones, set up a new fresh window. You can have a zone that, let's say there are two terminals. Here is the zone, let's say zone 1, for example. And over here, that would be the common point. And I would just draw the ground symbol here, but that's the common point. You could have the wires going, and this could be a switch, whichever the, yeah, that would be a switch, yeah, right? Open, close, open, close. And the switch would be normally closed, so the system is at ease. Or you can have an end-of-line resistor and of line resistor, EOL resistor. Here's an EOL, there's an EOL, EIO, okay? But if you want to hear EOL, that means end of line. Or east of Ladelite, no, London, Ontario, okay. So the other scenario would be, here's the zone, let's say same, zone 1, here's the common point, and you would have the switch at the end. This switch looks better than that switch. And you would have the end of line resistor there. Now, when the switch is normally closed, the zone is not looking for pretty much closed wire, well, dead short or 0 ohms. Of course, it's not going to be 0 ohms if the wire is 100 feet long. You're going to have a couple of ohms there. So the engineers have set up so there's a bit of a tolerance from which amount of ohms and to which resistance it's considered to be a 0. Now, the end of line resistor, it will be 48 kilos sometimes, or depends on whatever the system is. And of course, you're going to have to install the type of resistors that the manual requires. The resistor R. Okay. Now, in this case, the system is looking for this resistance. And then it's at ease. It's a little bit of additional type of a protection, because if this is closed, and if somebody finds a way to short the wire here, then the system doesn't know it happened. You open that switch, open the door, or whatever, then you're bypassing that, so the system still sees that thing as a closed loop. Over here, when you close that, then the system doesn't see that resistance that it wants to see. It sees a short, so that means somebody's mucking with it. All right? So that's for the most part, the alarms are done this way here. But you can set it up that way as well. Also, in some cases, which I try to not do, I never did that. But it is possible, because I just had a weird feeling about that. I wasn't trusting that type of, I'm just going to erase that here. Just fix that wire over there. So sometimes you would get both scenarios into one zone, like here, jump over, and here, and over here. And you would have another contact or sensor, and with the end-of-line resistor, it's connection. And you would tell the system that this is a zone doubler, or you're doubling the zones. So you would consider it to be two separate zones. So in that case, from a 8-zone board, you can have a 16-zone board. And the system would know how this works. I've never done it because I just don't trust that type of a scenario, but some of the systems have that possibility. If I want to have more zones, if I need more zones, because it's a bigger house, bigger store, bigger shop, bigger facility, then I just get something that's called zone expansion board, and I interface that connected to the main board, and that's how I do it. Or I get a wireless, sometimes you can get by with a wireless module, and the wireless zones also act as additional zones. So you don't have to use the wired zones. There are some wireless devices serving as sensors. So here is the end-of-line resistor. Now, end-of-line resistors should be installed in series in security alarms. Fire alarms, different thing. So an end-of-line resistor in a security alarm is not installed the same way as the end-of-line resistor in a fire alarm. But we'll talk about fire alarms later. Just I'm giving you a heads up. The end-of-line resistor, as the name says, it should be installed at the end of line. Because if it's installed right by the screw terminals, then it just doesn't serve its purpose. Okay. So what do they say here? What did I say? Single, normally closed or normally open window sensor. And here's single, normally closed sensor with the single end-of-line resistor, EOL. Now, motion sensors, wiring of the motion sensors. We are most of the time we're going to be interested in two types of terminals here. Here's the power, and here's the sensor. That's mostly how those things. Here's an infrared eye, because quite often, for the most part, you're going to install the infrared sensing motion sensors. But there are different sensors. Some of them are microwave sensors. They're sending microwave and looking at the reflection of the microwave. Or sometimes you have a double whammy that you have infrared and a microwave sensor together. So of course they are more expensive. There are certain motion sensors that are so-called pet-friendly. Pet-friendly sensor is going to bypass a live being up to 40 pounds or something like that. So that gives you, you can have a dog running around the house, and the alarm should not trigger. Should not trigger is the key word. In reality, it might work or it might not work. However, I always, when I installed my systems, I always tried to sell or installed the pet-friendly sensors, because pet-friendly sensors will reduce the possibility of false alarms. False alarms are bad because they are creating the cry wolf effect. You get so many false alarms, the monitoring station is not going to be looking as serious, or is still going to be looking seriously at every single alarm. But if there's obviously, naturally, if there's a house that keeps getting false alarms, the monitoring station people will have tendencies to think that this is just another false alarm if the real one happens. So that's no good. Plus, they will tell you, hey, you got to stop doing the false alarms, or we're going to have to charge you money, or we're just going to drop you. We're not going to, we don't want you, that system on because it's just tying up our personnel. So false alarms are bad. And sometimes false alarms, because monitoring stations get the alarm signals from the alarm systems, and then they call the police if that's one of the procedures that you requested. And when police when they go to respond to a security alarm, and if it's a false alarm, they will put that on their record. And they might just notify you, hey, you had a false alarm. So we're just letting you know. Second time it happens, they will say, you got 2 false alarms in this year. So now you're going to have to fix the problem, find the problem, fix it, and tell us what you've done to fix it. They will require that. Otherwise, they will not respond. And if you have a third one consecutively, and then they'll just drop you, and they will charge you money for producing false alarms. Now, it doesn't. The false alarms policies are different with the police departments by city. So the policies or the rules and regulations with false alarms in London, Ontario, might be different than Hamilton, Ontario, or Kitchener, Ontario. Every city entity, they have their own policies on how they handle the false alarms. But all across the board, police do not like false alarms. And eventually what's going to happen is that they'll either keep charging you money to the point that you will you will either turn off the alarm or fix it because it will cost you money, or they will just drop you. They will not service you. So over here and in the main board, let me just look at the main board here. Right here, it's these 2 terminals, and if you magnify it, it's right here. These 2 terminals provide power for the active devices. It's 12 volts DC, auxiliary power. Again, on the main board, different main boards will have different layouts, but this particular one has, so it's auxiliary power. It's an output, 12 volt DC, powering up devices. It doesn't have endless amount of current that you can provide and still keep 12 volts. So you have to find out from the specifications of this particular board how many amps it can provide and still be good. And you're going to have to with the motion sensor or any other active device, you're going to have to read how many amps it draws, idling, or how many amps it draws when it's, so you have to look at the current specifications. And then you add all the active devices and you just make sure that you don't exceed the ability of the power terminals on the main board. If you exceed the ability to provide amps or the current, then you just get an expansion board or a power expansion or power extender, whatever the companies, they will call it in different ways. Basically, it's a separate power supply with its own battery and its own charger for the battery, and it just gives you more power. So that in the Z wires, when we have red, green, black, and yellow, we use the black and red to connect to the power, and the other one goes to the auxiliary power. And here is just a signal. Now, sometimes those terminals are going to have screw terminals, normally closed and common. And you have the opportunity to plug it in to common and normally open, but usually you don't do that. In fact, some of the motion sensors, they will have that normally open, just blanked out, not even provided with the screw terminal for you to connect anything. Some of them do have it, most of them don't. And then there's the temp. What's the temp? It's a temper switch. If somebody's tempering with the device. Here is the chassis or the box in which the motion sensor board is enclosed. And it has those screw terminals. And over here, you see something that's called a temper switch. When you put the top cover on, there's a little bit of a pusher that pushes that switch into closed position. So if somebody wants to tamper with this whole thing, they're going to take the front cover off. And if they do, the switch becomes open. And that can be wired into a separate zone. But for the most part, if you want to utilize the tamper switch, then you would just put that switch in series with this with the signal wire. Okay. And the motion sensor, most of them are infrared. This is the lens, and if you turn it around, you're going to have different thicknesses of the plastic. So that's the lens for the infrared. We don't see that. This is just an LED to see that, to show you that the device is working or triggering or whatnot. Or you can disable that too. There are a bunch of jumpers here that you can set up. You can disable the LED as well. It's just an LED indicator. Doesn't change the operation of the whole thing. So the way things work for the infrared sensor, it registers a change in position of the infrared source. What would be the infrared light source? Infrared light is expressed as the warmth or the heat, which we, live human bodies, produce. And that thing is sensing it. If you're standing, not moving, this will not react. As soon as you move, the position of this within that lens and within the little analyzing element, it's going to notice that there is a different position of the infrared source, and that's when it's going to trigger. You can walk as slow as you want, and it's very difficult to bypass that. Of course, everything is bypassable, but I dare you to try this one. So, security alarm zone. Here is a security alarm. CP closed point. Okay. You basically can put different, as I said before, you can put different sensors in series and connect it to one zone to save the zones. If you have 3 windows in the same room, you don't want to put all of them on the different, well, because as I said, you're going to run out of the zone. So that's how things are. If you have different motion sensors, like 3, 4 motion sensors on the ground floor, and it makes sense to cascade them together, you're just going to run in series from one to another, and you can put that. Sometimes you're going to, there are different ways of doing that. You can do it like this, or sometimes what people do, they will have one sensor, whatever it is, another sensor, whatever it is, another sensor, whatever it is, and here is the zone, and they will have wires run to the panel from each device. Okay. From each device, you will have wires, and sometimes you would just connect this one to that one, this one to that one, and this here, you would connect that to the zone. Just keep in mind that you should not be doing this thing like with too many devices, because this just adds the overall length of the wire. Okay, and this zone has just certain tolerance on what it considers as closed loop and what resistance as an open loop. Well, open loop is the so-called infinite resistance, but the closed loop, you have to make sure that you don't exceed, because wires, they will add resistance, especially if they're long wires. So with the windows, I just go wang, 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 and then just do it that way. but sometimes you can get away with doing that. You just have to make sure that you don't exceed the specifications of the system. All right, as a summary for the security alarms, sensors. There will be motion sensors, door contacts, which are also installed on the windows, but we all call them door contacts, glass break sensors, smoke sensors, heat sensors, water level sensors, seismic sensors. Seismic sensors detect vibrations. Quite often they're being mounted on the safes in the banks. So if somebody is mucking with the system, with the safe, they will try to drill holes or something. It's going to sense that. Panic buttons, quite often installed by the receptions and stuff like that. So it's just a sensor. It's not. It's a switch. You push that button, it opens the loop, and it's programmed as a panic button. And the monitoring station gets the signal that zone 7 was triggered, for example. And what's zone 7? Oh, they connected the panic button to zone 7, so they will have a certain procedure to be triggered with the panic buttons. And the sensors could be wired or wireless. How is it that the glass break sensors detect, or how do they trigger? Well, when the glass breaks, it's looking for three things. Because the main idea is to trigger when it's supposed to trigger, but it's not supposed to trigger giving us false alarms. So when the glass break sensor sees or senses three things: the high-pitched sound of the glass breaking, preceded by the low-frequency rumble that just gets before the glass is broken. So those two frequencies are present. And some of them even are programmed to sense the sudden change in pressure in the room. And if all those three things are present, the glass break reacts. Most of them are just sensitized to the high and low pitch of the glass breaking, high pitch and low pitch sound, and they have to be present both almost at the same time for this thing to trigger. So you just don't want, it's like you have a cat, and your cat wanders around the kitchen countertop, and it knocks over some kind of a dish or a glass. The glass break will not sense because there's that no low frequency associated when the window is broken. Or if there's a storm, lightning storm, there's that rumble. Then yes, there is the low frequency rumble, but there is no high pitched noise. Although if the lightning hits close enough, you get both frequencies. So yes, it might trigger. Annunciators, as far as how is the system is going to let us know that it triggered. Bell, it is a siren, but we call them bells. Then there could be a strobe lights associated with the noise, and some of them are installed to be silent alarms. So it's armed, hidden out of the way. Nobody even knows the alarm system exists. Somebody breaks in, they won't even know that the system has triggered, and all of a sudden there's police at the door. Yeah. So it depends on your preference on how you want things to be installed. Control. How do we control those? Well, we control them with keypads, and some programming can be done through keypads, although the programming should be done through a laptop, PC, or some kind of a smart device like that. You want that graphic interface. You want to have that because keypads, some time ago, it was possible to program the whole thing with just a keypad, but they keep adding the features and things have become a little bit more complex. I want a laptop to program that with the software that you can see things and click things away or program things. And IP, well, an IP device can be interfaced with the main board, and the IP is connecting the alarm system. It's almost like a media converter. Right? It connects the alarm system to a network. So the IP will have a serial port connection, plugs into the serial port, and the IP box, little tiny box, has a jack, Ethernet jack on the other end. You just plug that into the network. So you can access the system for the programming through the client's network. So you don't even have to go and open the box and connect to the serial ports. So you can just bring your laptop, plug into the network, and if you know your credentials, passwords, users, and whatever the IP address is, then you can access the system. Or you can access remotely through the IP. So you can go, that can be interfaced with the cloud, with the internet. You can access through the internet. Wireless remote controls, like most of the security alarms, you can get a remote control to go with that too. You can use the remote control in various ways, just arm and disarm the system. You can arm the system with something that's called a stay arm instead of regular arm. A stay arm, and it requires a certain type of installation and programming that you can arm the system while you are in the house. So all the outside parameter is armed, and all the inside motion sensors and whatnot, they're going to be ignored. Quite popular thing to arm your house when you go to sleep. And you don't have to have a keypad at your bed, by your bed, in your bedroom. You can have the remote control. And you can just, before you go to sleep, you can just click and arm the house with the remote control. Also, remote control is a selling feature. We used to use that a lot, and the remote controls sold, and it's a legit reason. If you have that eerie feeling that something is not right when you come to your home, then you just go outside and arm the system. And if somebody is inside, they will move. The system will trigger. It's a good selling feature for the remote controls. Interfacing the alarm systems, security alarm system can be interfaced with access control. What's access control? It's the, in our college, we have the swipe cards to open and close the doors. That's access control system. So alarm systems can be interfaced with access controls, quite popular in the real estate agencies. The real estate agency will have a building, and they will give out the cards or the fobs, and they will be to the agents, and they could employ 120 agents or 80 agents. Not all of them be at the building at the same time, in the building at the same time, but they'll get the cards, the swipe cards, or the key fobs, and there will be a proximity sensor of the access control outside the door. So the agent, when they want to walk in, they could just swipe it and disarm the alarm by a single swipe and release the door strike so the door can open. If somebody quits, that card gets deactivated, and that's it. Otherwise, you would have to change the locks and cut everybody's another key, 120 keys, every time somebody quits, right? Which just doesn't make sense. So it's a very popular system, interfacing the access control with the security alarms. Security alarms can be together working together with the fire alarms. They can be sharing zones. Like, for example, if the fire alarm doesn't have monitoring connected, but the security alarm does, the fire alarm can be connected to one of the zones of the security alarm, and that zone can be programmed as a fire zone, and then you get the monitoring. Always check with the local regulations if you can do that. Right? Monitoring station. If the system triggers, it sends the signal to a monitoring station, not to the police. It never sends. Police never get the alarm signals. Monitoring stations do, and the monitoring stations notify the police. Right? So it could be just a noisemaker, or it could be a monitored system. And monitoring costs a certain amount of dollars every month to have that system monitored. It's a residual income for you if you have your own business. And some other devices that this thing can be, imagination is your limits. Wiring, as we said, cable Z4 for the most part. No twist, and I explained that already. And this is the old color code. That's what we use most of the time. We're going to use black and red for the power, for the devices that need to be powered, and the yellow and green, with most of the time the green connected to the common and the yellow to the to the signal. But let's just leave it at that. Okay. All right, so that's it for today. This is the second part of the security alarms, and the next week we're going to tackle the fire alarms and the security surveillance or the security cameras in 1 week. All right. Thank you for your attention, and I'll see you next time.